Welcome to Science Pills. Today we are doing a serious and honestly a pretty thrilling deep dive into the latest discoveries regarding the 1977 WOW signal.
Yeah, it is, it's quite the journey.
It really is. I mean, we are focusing heavily on the potential source star 2MASS 1T281282 minus 2640123, which is a mouthful.
Oh, absolutely.
And we're also going to get into the Arecibo WOW project's massive 2024 to 2026 findings, linking the signal to stimulated emission from cold hydrogen clouds triggered by magnetar flares. Plus, we have to talk about Avi Loeb's theory regarding the interstellar object 3I Iadios.
Right, because you can't talk about modern astrophysics without Avi Loeb popping up somewhere.
Exactly. And to do all this, we've pulled together a massive stack of sources for you. We're looking at the foundational archives, the August 2025 Arecibo WOW, to preprint updates from the Planetary Habitability Laboratory at UPRC Poyabo, and this really fantastic March 2026 YouTube breakdown from India.
Yeah, their visual breakdowns are incredibly helpful.
They really are. We also pulled from a Futurism article on Loeb's theories and some great recent reporting from Space.com and the Economic Times.
So we have a lot of ground to cover.
We do. And our mission here is to take you on a journey from the initial just total awe of 1977 all the way to the groundbreaking discoveries from the last couple of years that finally decode this 50-year-old enigma. We are looking at exactly how modern science is rewriting our understanding of the cosmos.
Right, and I think it's important to frame the stakes here right at the top. As the resident astrophysicist for this deep dive, I can tell you this isn't just about, debunking or confirming aliens.
Right.
It's really a masterclass in how science actually works. Like how we synthesize decades of dusty archive data, how we challenge our own assumptions, and how we discover entirely new astrophysical phenomena that we didn't even know were possible.
Yeah, it's like a cosmic detective story. But, okay, before we can even begin to understand the new 2026 solutions, we have to deeply understand the anomaly itself. Why did this specific signal haunt astronomers for half a century?
Well, to get that, you have to put yourself in the room.
Okay, let's unpack this. Set the scene for us.
Right. So imagine it's August 15, 1977. You're at The Ohio State University's radio telescope, which everyone called the Big Ear.
The Big Ear. Great name.
Yeah, very literal. And astronomer Jerry Ehman is sitting there reviewing these endless stacks of computer printouts.
Just like reams of paper.
Exactly. Yeah. Continuous fan-fold paper, just chugging out an old IBM printer. And he's looking at columns of letters and numbers that mostly just represent random cosmic static.
Just the background hum of the universe.
Right. But then he sees this one specific sequence. It's so anomalous that he grabs a red pen, circles it, and writes, "Wow," in the margin.
And the sequence was a 6, an E, Q, U, J, and a 5.
Yeah. 6EQUJ5.
Which, to anyone else just looks like a Wi-Fi password.
It really does. But you have to understand the alphanumeric intensity scale they were using, because the computers back then couldn't draw nice, pretty graphs of radio waves.
Right. Memory was super limited.
Exactly. So they used numbers 1 through 9 to represent low-intensity signals. Basically, how many standard deviations above the background noise a signal was.
Okay, so a 1 is just a tiny blip.
Right. But when a signal gets louder than a 9, the computer switches to letters. So A is an intensity of 10, B is 11, and so on.
So when you get to U...
When you get to U, you are looking at a staggering 30 standard deviations above the background noise.
Oh, wow.
Yeah. It is an impossibly loud spike of energy.
So the signal starts at 6, builds up through E and Q, peaks at U, and then drops back down through J and 5.
Exactly. It's a perfect bell curve.
Yeah.
And the whole thing lasted exactly 72 seconds.
Okay. And why is that 72 seconds so important? Because that's a very specific number.
It is. The Big Ear was a fixed telescope. It couldn't turn its head, so to speak. It just stared at the sky while the Earth rotated.
So the sky is just sort of panning across its field of vision.
Right. And based on the width of the telescope's focus and the speed of the Earth's rotation, any object in deep space would take exactly 72 seconds to pass through the beam.
So it takes 36 seconds to reach the center, which is the loudest part, the U, and 36 seconds to leave.
Exactly. That 72-second window proved that the signal was coming from a fixed point in the stars. It wasn't a local radio station, it wasn't an airplane, it wasn't a glitch.
It was something out there.
Yes. But the intensity and the shape of the wave are only half the story. The really mind-blowing part is the frequency it was broadcasting on.
Right, the 1420.456 megahertz.
The hydrogen line.
Okay, break that down for us. Why is hydrogen so crucial here?
Well, hydrogen is the most abundant element in the universe. And neutral hydrogen atoms vibrate and emit a very specific faint radio wave at exactly 1420 megahertz.
Okay.
And in 1959, two physicists from Cornell published a paper predicting that if an alien civilization wanted to communicate with us, they would use that exact frequency.
Because it's a universal constant. Like, if you're smart enough to build a radio, you're smart enough to know about hydrogen.
Exactly. They called it the cosmic water hole. It's a very quiet frequency, free of a lot of standard cosmic background noise. It's the logical place to say hello.
Okay, let's unpack this, though. Because space is loud, right? Why couldn't they just brush this off as a black hole doing something weird, or, a pulsar?
That's a great question, and it's exactly what the Maindi breakdown analyzed so well. Pulsars and black holes are incredibly powerful, yes, but their radio bursts are messy.
Messy how?
They're noisy, they're distorted, and they're wide band, meaning they blast radio waves across a huge chunk of the dial all at once.
Okay, so if the cosmic background is like a raging hurricane of static,
Right.
the wow signal was like a single perfectly clear piano note just cutting right through the store.
That is the perfect analogy. The wow signal was impossibly clean. It was a narrowband, continuous wave. Natural phenomena just didn't do that. Not as far as anyone knew in 1977.
So they see this perfect piano note playing exactly where the aliens are supposed to be playing it. Naturally, they want to find out where the piano is.
Of course. And this is where the investigation hit its first major roadblock. It's called the twin horn problem.
The twin horn problem, which sounds like a fantasy novel, but it's actually an engineering flaw, right?
Sort of, yeah. To cancel out Earth-based noise, the big ear had two feed horns listening to the sky slightly apart from each other.
Okay.
The signal hit one of the horns, but not the other, which proved it was from space. But the way the computer recorded the data, it didn't specify which horn caught it.
Ah, that is so frustrating.
It's agonizing. So we were left with two possible coordinates in the sky, right in the constellation Sagittarius.
Near the M55 star cluster.
Right. So for decades, astronomers are just staring at these two blank spots in Sagittarius, looking for a suspect.
And it took until, what, 2022 to get a solid lead?
Yeah. Alberto Caballero published a paper in 2022. He combed through the massive Gaia satellite database, looking at all the stars in those two specific patches of sky.
And he was looking for something specific, right? Like a sun-like star.
Yeah, exactly. A G-type main sequence star. The logic being, if life evolved around our sun, maybe it evolved around a similar star out there.
Makes sense.
And he found one.
Yeah.
2M MASS, 1-28-1982 minus 2640123.
I really wish they gave these stars better names.
I know, it's a lot of numbers. But this star is a near-perfect twin of our sun. The temperature, the radius, the luminosity, they all match up incredibly closely.
And it's 1,800 light years away, which, I want to bring this up because it's a crazy detail. That distance is super relevant to the Drake equation, isn't it?
Yes, the Drake equation, which estimates the number of active extraterrestrial civilizations in the Milky Way.
Right.
A researcher named Claudio Micone did a deep statistical analysis of the Drake equation, and he predicted that the nearest alien civilization should be about 1,932 light years away from us.
And this 2MASS star is 1,800 light years away.
Yeah, it is just 132 light years off from the statistical prediction.
Which is basically next door in cosmic terms.
It is a striking coincidence. So naturally, the astronomy community went all in. In May 2022, the Breakthrough Listen project took over.
And they have serious hardware.
Oh, the best. They used the Green Bank telescope and the Allen telescope array to just drill down on this specific star. They were looking for any sign of a techno signature and complete silence.
Nothing.
Nothing. The star was totally dead in the radio spectrum.
Okay, I have to push back here because this is the thing that always bugs me about the alien theory. If there's an alien civilization around this sun-like star and they supposedly sent a signal in 1977, why the total silence? I mean, why would you send a massive 72-second signal basically screaming into the void and then just hang up the cosmic phone for 45 years?
This raises an important question, and it's the core problem with the WOW signal. In science, if an event doesn't repeat, it is maddeningly difficult to study.
Right.
But if we're playing devil's advocate for the alien theory, we have to talk about transient events. Maybe the signal wasn't a targeted beacon aimed right at Earth.
In the lighthouse.
Exactly. If they were sweeping a powerful beam across the entire galaxy, it might only hit Earth for 72 seconds every few centuries.
Okay, so we just got lucky or unlucky, depending on how you look at it.
Right. Or perhaps we were looking at the right map, but looking for the wrong type of object. which leads us to some of the alternative theories.
Right, because if it's not a star, what is it? A comet? I know there was that 2017 theory by Antonio Paris about comets.
Yes, Paris suggested that hydrogen clouds surrounding passing comets might have emitted the signal, but that was widely discredited.
Why?
Because comets simply don't emit strongly enough at 1420 megahertz. It completely fails to account for the sheer massive intensity of the WOW signal. It ruled out simple, local solar system interference.
Okay, so if it's not a local comet and it's not a distant stationary star, what if it was an interstellar object, something moving through the field of view? This is where it gets really, really interesting because it transitions us to Avi Loeb's theory.
Ah, yes, Avi Loeb from Harvard. He published a very provocative proposition in September 2025.
And Loeb loves a controversial theory. I mean, he's the guy who suggested Oumuamua was an alien light sail.
He is never afraid to push the boundaries, that's for sure. And his 2025 paper focused on a recently discovered interstellar object called 3I Attilas.
Which is only the third object from outside our solar system we've ever found, right?
Exactly. And Loeb calculated its trajectory backwards in time to see where it was in August 1977.
And where was it?
It was deep in our outer solar system, about 600 astronomical units away.
Wait, an astronomical unit is the distance from the Earth to the Sun, right?
Yes, so 600 times that distance. Very far out. But crucially, Loeb found that its position in the sky back then aligned almost perfectly with the WOW signal's coordinates.
What are the odds of that? Just a random rock lining up perfectly with the telescope at the exact right time?
Loeb calculated the chance of a random alignment at a mere 0.6%.
That is incredibly low.
It is. But Loeb didn't just stop at the alignment. He did the math on the power requirements. If 3I Atlas actually emitted the WOW signal from 600 AU away, how much power would that take?
Okay, and what was the number?
To hit the big year with 30 standard deviations of intensity from that distance, the object would need a transmitter pumping out 0.5 to 2 gigawatts of power.
2 gigawatts?
Yes.
That's equivalent to a typical Earth nuclear reactor.
Exactly. A massive industrial power plant.
So Loeb isn't saying it was a natural emission from a rock. He's saying it's a machine.
Yes. He explicitly warned about the possibility of a black swan event. He used the term Trojan horse, the idea of an alien probe disguised as a comet arriving in our solar system. He even suggested we need contingency plans for first contact.
That is wild. I love the analogy here. It's like, imagine someone shining a laser pointer directly into your eye from a speeding car 100 miles away. Is that just incredible aim or incredible coincidence? Because if it's aim, that is terrifying.
It is a very evocative image. But as a scientist, I have to provide some critical analysis here. Loeb's theory, while absolutely fascinating, requires enormous leaps of faith assumptions about alien technology.
Right. We have to assume they exist, that they build Trojan horses, and that they use gigawatt lasers.
Right. And science requires replication. As of right now, no radio telescope has detected any radio data from 3I Atlas around the hydrogen line.
It's silent.
It is currently completely silent, so making it the source of the wow signal is highly speculative.
Yeah.
Wonderfully imaginative, but we need hard evidence.
Okay, so if the source wasn't an alien megastructure on a sun-like star, and it wasn't a nuclear-powered Trojan horse zooming through our solar system, what the heck was it?
This is where we pivot from high-concept alien theories to the really gritty, meticulous space archaeology.
Space archaeology, I love that term. And this really relies heavily on the research that just came out between 2024 and 2026.
Yes, and it all actually starts with a pretty heartbreaking event for the astronomical community.
Yeah.
The collapse of the Arecibo Observatory in December 2020.
Oh man, yeah. Arecibo, that was devastating. I remember watching the footage of the massive platform just snapping and crashing into the dish.
It was a huge loss. Arecibo was iconic. But in the immediate aftermath of that collapse, a researcher named Abel Mendez from the Planetary Habitability Laboratory, he basically rushed in to save and copy as much data as possible.
Literally pulling hard drives from the wreckage?
Essentially, yes. He was securing decades of observations. And years later, while his team was analyzing that saved Arecibo data from between 2017 and 2020, they made a massive discovery.
What did they find?
They found what they called mini-WOWs.
Mini-WOWs, like smaller versions of the original signal.
Exactly. They found narrowband signals clustered near the hydrogen line. Now, they were much less intense than the 1977 scream, but structurally, the waveform was incredibly similar.
Wait, really? Because for 50 years, the narrative was that the WOW signal never, ever repeated. And you're telling me it was just sitting in the Arecibo hard drives?
Yes. Modern data analysis tools allowed them to spot patterns that human eyes or older algorithms just missed. And they didn't stop there. In August 2025, the PHL team published the Arecibo WOW preprint.
Okay, what was in that paper?
They managed to retrieve and digitize decades of unpublished original Ohio SETI data from the big ear itself, from right after the original WOW signal.
So they went back to the original telescope's raw archives.
Yes, and they found similar signals from 1978. They dubbed them WOW2 and WOW3.
Oh, wow. So it absolutely repeated. We just didn't know what we were looking at.
Precisely. And by applying modern computing power to this old data, they were able to revise the original parameters of the 1977 event.
Okay, how did the parameters change? Did they figure out the twin horn problem?
They did narrow down the potential origin coordinates significantly to specific fields in Sagittarius. But more importantly, they discovered the signal was actually much stronger than we thought. They calculated a higher peak flux of over 250 Janskys.
Okay, wait. Let's pause for a second. What is a Jansky?
A Jansky is the standard unit of measurement in radio astronomy for the strength of a signal.
Okay, and is 250 a lot?
Yes. 250 Janskys for a narrowband signal originating from deep space is absolutely deafening. But the most crucial revision they made was to the exact frequency.
I thought the frequency was exactly the hydrogen line, the 1420.45556.
Well, the Arecibo team's advanced analysis pinpointed the true frequency of the 1977 signal at 1420.726 megahertz.
Okay, so it's slightly off from the baseline. Why does that tiny fraction of a megahertz matter so much?
Because that frequency shift implies movement. It's the Doppler effect.
Right, like an ambulance siren changing pitch as it drives past you?
Exactly. Because the frequency was slightly higher than the baseline hydrogen line, it means the signal was blue shifted, which tells us that whatever emitted it was moving toward Earth with a much higher radial velocity than previously assumed.
So it's a galactic source and it is moving fast.
Yes. But the real smoking gun came when when Mendez's team looked at what exactly Arecibo was pointing at when it caught those mini-wows between 2017 and 2020.
Okay, what were they looking at?
Every single time Arecibo saw one of these signals, the telescope was pointed dead at an interstellar cloud of cold hydrogen gas.
Wait, cold hydrogen gas, just a cloud?
Yes, what astronomers call HI clouds.
Okay, hold on. This is where I need you to connect the dots for me. Because we just established that this signal was 250 Janskys. It was a deafening scream of energy. How does a cold, lazy cloud of space gas suddenly produce a blast of radio waves that loud? Cold gas doesn't just explode with radio energy on its own, right?
No, it certainly doesn't. And that brings us to the grand synthesis of this whole mystery. The cold hydrogen gas naturally emits weak radio waves at 1420 megahertz. But to get that massive energy spike, you need a trigger.
Something to light the match.
Exactly. And astrophysicists have zeroed in on the culprit. A transient strong radiation source, specifically a magnetar flare or a soft gamma repeater.
Okay, what is a magnetar, for those who don't spend their weekends reading astrophysics journals?
A magnetar is a type of neutron star with an insanely powerful magnetic field, trillions of times stronger than Earth's. And occasionally, the crust of these stars literally cracks under magnetic stress.
Like a starquake.
Yes, a starquake. And when that happens, they release a catastrophic blast of radiation, a soft gamma repeater flare.
So we have this massive blast of energy. How does that interact with the cold gas cloud?
It creates a mechanism called stimulated emission, or superradiance.
Okay, walk me through that.
Imagine the magnetar is sitting behind the cold hydrogen cloud from our perspective. The magnetar flares, blasting the cloud with high-energy photons. The cold hydrogen atoms absorb this energy, and their electrons get bumped up into a higher excited energy state.
Okay, so the whole cloud is suddenly supercharged.
Yes. But they can't stay in that excited state forever. When one atom drops back down to its normal state, it releases a 1420 megahertz photon.
The hydrogen line.
Right. And here's the magic part. That photon hits another excited atom, which stimulates it to release its photon in the exact same phase and direction.
Oh, it's a chain reaction.
Exactly. It creates an avalanche of perfectly synchronized photons. The cloud essentially lasers. It becomes an astronomical maser.
A maser. Microwave amplification by stimulated emission of radiation.
You got it. The cloud temporarily becomes a giant, naturally occurring radio laser.
So what does this all mean? If I'm trying to picture this, it sounds exactly like a neon tube.
Oh, that's a brilliant way to look at it.
Right, like the gas inside a neon sign is invisible and completely silent. But when you zap it with a massive jolt of electricity from the power supply, the whole tube flashes bright and loud for a brief moment.
What's fascinating here is that this analogy scales perfectly to the cosmos. That is exactly what happened. The magnetar provided the electrical zap, and the hydrogen cloud was the neon tube.
And it flashed for exactly 72 seconds.
Well, the flash itself might have lasted longer, but it matched the 72-second sweep of the Big Ear telescope perfectly. And this explanation just neatly ties up every single loose end.
It really does, because it explains why the signal was so narrowband and clean, because that's how masers work. They emit coherent light or radio waves.
Exactly.
And it explains why it was exactly on the hydrogen line frequency, because the cloud was literally made of hydrogen.
Yes. And it explains the temporary duration, and most importantly, why it never repeated in that exact spot with that exact intensity.
Because the magnetar flare passed, the zap ended, and the neon tube went dark again.
Precisely. It was a transient event, and we now believe this was the first recorded instance of an astronomical hydrogen maser flare.
And you mentioned earlier that there was a My India report about computer simulations.
Yes. The March 2026 report. Researchers actually ran this exact scenario through advanced supercomputer simulations. They modeled a cold hydrogen cloud being hit by a magnetar flare.
And what happened in the simulation?
The simulated cloud reacted identically to the theoretical model. It became excited, experienced a population inversion, and emitted a high-intensity 1420 megahertz signal. The simulation perfectly mirrored the 1977 WOW signal event.
That is just, it's incredible. So we can say with, what, 99% certainty that it was a natural astrophysical event?
Yes, it is 99% confirmed, not aliens. A magnetar-triggered hydrogen maser.
Man, on one hand, it's a huge triumph of science. On the other hand, it's a little sad, right? No aliens saying hello.
I understand the disappointment. But in the scientific community, this is massive. Because knowing what the WOW signal likely was actually changes the entire landscape of the ongoing search.
How so?
Well, it gives us a new baseline for false positives. We now know definitively that natural masers can perfectly mimic alien technosignatures.
So if we see a loud, narrowband spike on the hydrogen line tomorrow, we won't immediately jump to it's aliens. We'll ask, is there a gas cloud there?
Exactly. It makes our search parameters so much more rigorous. And the really exciting part is how the search itself is changing, the democratization of astronomy.
Right. I wanted to make sure we talked about this, because the Arecibo didn't just solve the mystery and walk away. They launched a citizen science project.
Yes. The WOW at Home project.
So how does that work? How can a regular person listening to this podcast, this deep dive, how can they get involved?
It's remarkably accessible. Because these maser flares are so intensely loud, you don't actually need a massive government-funded dish to hear them.
You don't need the big ear.
Exactly. You can detect them with a small, commercial, software-defined radio setup, an SDR.
And how much does a setup like that cost?
For about $500, anyone can buy the necessary antenna and receiver. And the Arecibo team has provided the software for free.
So you just set it up in your backyard, and the software autonomously monitors the sky for transient events in real time.
Yes. It runs quietly in the background, continuously analyzing the incoming radio waves, looking for those specific maser profiles. It essentially networks thousands of amateur dishes into one giant global observatory.
That is mind-blowing. The shift from relying solely on giant government dishes to a global network of amateur astronomers scanning the skies from their patios.
If we connect this to the bigger picture, it's exactly what astronomy needs right now. Because professional telescopes are overbooked, and the universe is absolutely full of other anomalies that we still can't explain.
Right, because solving the signal didn't solve everything. The Economic Times had a great piece recently about all the other weird stuff we're seeing. Like, what is ASCAP J1832-0911?
Yes. That is a truly bizarre object. It's a radio source that is pulsing intense energy exactly every 44 minutes.
Every 44 minutes, like clockwork.
Yes. And it's doing things that our current models of stellar physics say it shouldn't be able to do. It defies our understanding of neutron stars and white dwarfs.
And then there are FRBs, fast radio bursts, like FRB 2022-610A.
That one is particularly staggering. It's a fast radio burst that originated from 8 billion light years away.
8 billion. The energy required for us to see a flash from that far away is incomprehensible.
It is. We are still debating what causes FRBs.
And then, of course, there's the search for life itself, which is shifting away from radio waves and toward atmospheric analysis. like exoplanet K218b.
Oh, right, K218b. That's the one where the James Webb Telescope found signs of dimethyl sulfide, right?
Yes. Dimethyl sulfide is a molecule that, at least here on Earth, is only produced by life, specifically marine life like phytoplankton.
So we are finding actual chemical signatures that point toward biological processes rather than just hoping to catch a stray radio broadcast. Exactly. The search is maturing.
Well, this has been an absolutely incredible journey. Let's just concisely recap what we've covered today.
Let's do it.
We started in 1977 with Jerry Ehman staring at a confusing 6EQ UJ5 printout from the Big Ear telescope, a 72-second, incredibly loud, narrowband signal right on the hydrogen line.
We talked about the frustrating decades of searching, the twin horn problem, and the identification of the sun-like star 2MASS 1928-1982 minus 2640123.
We went down the rabbit hole of Avi Loeb's interstellar object theory, looking at whether the 3I Antilles comet could have been a gigawatt-powered Trojan horse.
And then we broke down the actual empirical truth, the 2024 to 2026 Arecibo WOW project discoveries, the space archaeology that found the mini-WOWs, and the 1978 WOW2 and WOW3 signals.
And finally, the revelation that the signal was a naturally occurring hydrogen maser flare triggered by a magnetar starquake, a cosmic neon tube.
It really is a beautiful scientific resolution.
It is, and I want to remind you, the listener, that science is a living, breathing process. The ignored, dusty data of yesterday holds the groundbreaking discoveries of tomorrow, and you can literally join the search via the WOW at Home project.
It's a very exciting time to be looking up.
It really is, and I want to leave you with a final thought to mull over. For 50 years, we thought the WOW signal was an attempt by a lonely alien race to say hello. But what if it was actually the universe itself, using the building blocks of reality, cold hydrogen and magnetic fire, to remind us that the cosmos is capable of singing songs far more complex than we ever imagined?
It's a beautiful perspective.
Because if the universe can spontaneously create a radio laser, what other impossible natural wonders are waiting out there in the dark, masquerading as magic? Thanks for joining us on this deep dive.